For the last decade, I feel like we've built machine learning infrastructure around this one core, totally non-negotiable principle, right? Absolute predictability.
Oh, yeah, completely. You want it locked down.
Exactly. I mean, you write your YAML files, you commit your deployment scripts to Git, the CI/CD pipeline runs exactly as written, and the engineers can just point to the terminal and say, like, there it is. It's deterministic.
It's a very comforting paradigm. Enterprise infrastructure is, well, it's supposed to be boring. A system does what you tell it to do, when you tell it to do it, and literally nothing more.
Right, which is exactly why looking at the official technical documentation and the architecture diagrams for the HumAIne Swarm Assistant is, I mean, it's simultaneously fascinating and completely terrifying.
I can definitely see why you'd say terrifying. It's a huge shift.
It is. So for you listening, welcome to the deep dive. Our mission today is to tear down the architecture of this new MLOps assistant. But we're looking at it from the perspective of two technical architects evaluating a new enterprise tool. And I'm going to be completely upfront here. I'm adopting the role of the skeptic today.
And I'll be the, hopefully, calm systems architect trying to explain how they actually implemented this thing safely.
Good luck with that. Because for you listening, you might be wondering how an AI assistant can seamlessly query project docs, run Kubeflow pipelines, and compare Minio model metrics all in a single chat interface. We're going to pop the hood and see exactly how it's wired. So, okay, let's unpack this.
Let's do it. Where do you want to start?
Well, before an assistant can execute these crazy, complex MLOps pipelines, it needs a brain, right? It needs to understand the project. So we have to start with a knowledge base. The docs outline a retrieval-augmented generation setup, a RAG pipeline.
Right. The RAG setup is foundational here.
But here's my first skeptical question. With like a million vector databases out there right now, I mean, everything has a vector database bolted onto it.
Yeah.
Why was Pinecone the chosen architectural foundation for the HumAIne project?
Well, the choice really comes down to decoupling the heavy compute from the real-time chat experience. They didn't want the application itself managing vector storage.
So they outsourced the headache.
Basically, yeah. The docs show the index is hard-coded as HumAIne, and it uses a serverless setup hosted on AWS.
AWS. In which region?
Specifically in US East 1. And it relies on the dot product metric for similarity searches.
Okay, standard enough.
Yeah.
But how does the data actually get in there? I mean, MLOps documentation isn't exactly light reading.
What's fascinating here is how the system separates the heavy lifting of data injection from the real-time retrieval. The data pipeline is actually super clever.
Clever how? I'm looking at the injection script, dateinjection.py. It uses LangChain's PyPD floater to pull from a local .docs folder. But standard PDF loaders usually just like mash every single page into one massive, endless string of text.
Yeah, they do.
So if I feed it a 50-page Kubeflow research paper, it generates a monolithic block. And vector embedding models absolutely choke on inputs that large.
Right, which is why that massive string doesn't go straight to the embedder. The HumAIne team takes that text and passes it into LangChain's semantic chunker.
Semantic chunking.
Yeah.
Because a naive implementation would just, slice the text every 500 characters and call it a day.
Exactly. And if you do that, you end up with like a Python code snippet or a Kubernetes YAML file chopped right in half.
Which renders it totally useless to the AI.
Exactly the problem. So this architecture uses a gradient breakpoint threshold type. It mathematically evaluates the semantic meaning of the sentences sequentially.
Wait, how does the script know where a thought ends?
Well, it calculates the cosine distance between the embeddings of individual sentences. When it detects a sudden spike in that distance, meaning the semantic relationship between sentence A and sentence B has drastically changed, it says, the topic just shifted.
Oh, wow. So it uses that natural shift in meaning as the breakpoint. It's dynamically finding the logical paragraphs, even if the PDF formatting is garbage.
You got it. Only then are those perfectly grouped segments passed to OpenAI's text embedding 3 small model and finally batch absurded into Pinecone.
Okay, I have to admit that injection flow is clean. But let's look at the real-time side, the getDocs tool.
Right, the retrieval part.
The docs say it uses a similarity topic A10 to pull context into the chat, meaning it grabs the top 10 chunks of text every time I ask a question.
Yes, to give the LLM highly targeted context.
But this is a glaring flaw in every long technical chat I've ever seen. If I'm diagnosing a 50-step machine learning pipeline, I might ask, 10 follow-up questions. How does the app not just completely crash the token limit?
The dreaded context window exhaustion.
Yeah, I mean, I always compare context windows to a strict bouncer in a club. The club has a hard maximum capacity. Once it's full, if a new piece of information wants to come in, the bouncer has to forcefully kick something else out.
Yeah.
So how does HumAIne choose what to kick out without breaking my entire workflow?
Well, the app uses a dedicated component for this exact bouncer logic. It's called the User Session Manager. And it doesn't just guess how full the club is, it calculates it with absolute precision.
Using what?
It uses tick token, specifically the encoding for the GPT-4 mini model, to count tokens exactly.
Wait, tick token. But why go through the computational overhead of counting exact mathematical tokens? Wouldn't a sliding window of, say, 100,000 characters be infinitely easier?
It would be easier, but it's incredibly dangerous for an MLOps assistant. Think about what this AI is doing. It's generating complex JSON payloads to trigger Kubeflow pipelines.
Oh, I see where this is going.
Yeah. If you use a dumb character count, your sliding window might accidentally truncate the first half of a required JSON bracket in the chat history.
And then the JSON parser fails, the tool call breaks, and the whole agent crashes.
Exactly. In fact, here's a surprising fact from the source code. There's actually an older character-based truncation function called manage_cut_history sitting in the utils file.
Wait, really? They left it in there?
Yeah. But the app ignores it entirely now in favor of the much more precise tick token method. They clearly realized character limits were too brittle.
That's hilarious. Okay, so how does the math actually work for the token limit?
It calculates a strict max input tokens limit. It takes the max context length and subtracts the max token setting, which is the reserved space for the AI's response.
Okay, so the bouncer knows exactly how many seats are left. But who gets kicked out, and what stops the bouncer from kicking out the AI's core instructions?
Good question. The User Session Manager strictly protects the initial system prompt. That core set of rules is never, ever forgotten.
Okay, good. The Constitution is safe.
Right. And then it just drops the oldest user and assistant messages from the very front of the queue until the total count fits within that limit.
Right. Memory is handled safely. But here's where it gets really interesting and where my blood pressure spikes. Security.
I knew it'd get here.
We have to. Because the assistant is making actual executable API calls to Kubeflow and Minio. It's not just summarizing text. How on earth does the app safely authenticate user actions so the LLM doesn't just go rogue and delete someone else's model artifacts?
It's the most critical piece of the architecture. And they solve it with a dual-layer security model. It combines a keycloak oath flow with a Minio STS assume a role mechanism.
Okay, let's walk through the user journey. I open the Chainlet UI. What happens?
The @keyl.o oath callback hits the keycloak provider. You log in via your organization's SSO.
Standard enough.
But then it extracts your user namespace from the claims or roles something like Kubeflow username and locks that into your session metadata.
So the AI is physically sandboxed to my Kubernetes namespace from the start. Exactly. But the Minio STS magic is where it gets really secure.
Minio STS, Security Token Service. Right. Instead of sharing hard-coded root keys with the AI, the app uses a function called fetch Minio credentials from Keycloak. It takes your OAuth access token and posts it to the Minio send point.
Using what exactly?
A mechanism called assume role with web identity.
Okay, let me translate this. So it's not giving the AI a master key to the building. It's taking my ID and giving the AI a self-destructing VIP badge that only opens the doors the user is already allowed to open.
That is exactly what it's doing. It returns temporary user-scoped credentials, an access key, a secret key, and a session token.
And they expire.
Yes, with a strict expiry. And the user session manager constantly checks if those credentials are valid. If the expiry is under 5 minutes, it refreshes them.
And if the token fully expires, like I go on for the weekend and come back,
it forcefully clears the session, it wipes the history, and forces a complete relogin.
Honestly, I love that. It enforces security natively at the infrastructure layer, completely bypassing the AI's judgment.
Which is the only safe way to do it.
Okay, so the architecture is rock solid on security and context. The logical next step for an architect is deployment. How hard is this to actually provision? Do I have to compile a massive MLOps stack from scratch?
Not at all. And if we connect this to the bigger picture, it shows the project prioritized frictionless developer adoption. The docs provide a super straightforward getting started path via Docker Hub.
Docker Hub. So I don't even have to build the image locally.
Nope. You simply pull the pre-built image.
What's the configuration look like? Just a massive .env file?
No, it's just a few crucial keys. You need your OpenAI API key, your Pinecone API.
Okay, the AI brains.
Right, and then your Oath Keycloak client secret and your Kubeflow host. That's it.
Wait, really? Just those 4?
Just those 4. You run the container, pass the .env file, and point your browser to localhost 0.800.
That's incredibly lightweight for something this complex.
It really is. It makes adoption so much easier for teams wanting to test Swarm capabilities.
Well, you've definitely answered my skeptical questions today. So for you listening, what's the big takeaway here? Building an AI assistant for highly technical, secure environments isn't just about throwing API calls at an LLM.
Far from it.
Right. It requires rigorous state management with tick token, highly isolated STS authentication, and a really solid vector database implementation like Pinecone.
It's all about putting strict guardrails around an unpredictable system.
Exactly. But before we wrap up, I want to leave you with a final thought to mull over. Right now, the HumAIne Swarm Assistant acts as a secure bridge between a human researcher and the MLOps infrastructure, using temporary keycloak credentials tied to a person.
Tied to their specific human identity, right?
But as swarm learning evolves to include multiple AI agents collaborating together, how will these agents securely authenticate with each other to negotiate training pipelines autonomously?
Oh, wow. Without a human logging in to generate that initial OAuth token.
Exactly. Could agent-to-agent STS tokens be the future of enterprise AI? It's a whole new frontier for security architecture.
That is a fascinating problem to think about.
It really is. Something to keep an eye on as these platforms evolve. Well, that's it for our deep dive today. Thanks for joining us.
Thanks, everyone.